This is the new section on the vector spaces. Till now we have done the row space and row rank of a matrix. So now we are going to start the column space and column rank of a matrix. So the definition for the column space is, let A is the matrix in the form Aij and it is of the type n by n. So I can write this matrix in the matrix form as A11, element present in the first row and first column, then the element present in the first row and second column. How many number of columns are there? N. This denotes the number of rows and this denotes the number of columns, right? So there are total n columns. So it is then first row, third column, then so on, first row, nth column, right? And then the second row, first column, second row, second column, second row, third column, so on, second row, nth column, right? How many rows are there? Total m rows. So mth row, first column, mth row, second column, then element present in mth row, third column, so on. It is amn in the last, right? Now I can also write this matrix in another form. Let's say this be your first column and this is second column, this is third column, so on, this is nth column. So writing this in another form as C1, C2, C3 up to Cn, right? So this A matrix, this Bm by n matrix over the reals, then the vector space generated by the columns C1, C2, C3 up to Cn of A is called the column space of A, right? And column space is denoted by Ca, that is the column space of matrix A. Please note over here, column space of A is a subspace of R m by 1 vector space, right? This is a vector space having m number of rows and 1 column only, right? Why it is a subspace of this vector space? Because each column of matrix A is consist of m number of real elements, right? So each column is having m real elements of matrix A. Second, the definition for the column rank. Column rank is what? It is the dimension of the column space of A. So this is called the column rank, and column rank is denoted as row C of A, right? That is the column rank of A. Thus, column rank of A is equal to the dimension of column space of A. Next, we need to prove this remark. If A is an m by n matrix over reals, then column rank of A is equal to minimum of m or n, where m is the number of rows and n is the number of columns. Please take this as your remark also. Now what is given to us? A m by n matrix is given to us. So since the column space of A is generated by how many vectors? The columns of A, that is n vectors, right? So these vectors are the columns of A, as column space of A is a vector space generated by the columns of A. So therefore, the dimension of column space of A must be less than equal to n, right? Because it is having the number of vectors as n, right? Please mark this as 1. Now again, since we also know that column space of A is a subset of vector space m by 1, right? And what is the dimension for this? Dimension of vector space m by 1 is equal to m multiplied with 1, that is m, right? In general, you can also notice that the dimension of vector space R m by n, if this is of the type, then dimension of this vector space is equal to m into n, that is equal to mn, right? So the multiplication of the number of rows into the number of columns is the dimension of the vector space of the type m by n, or whatever number of rows or columns may be. So as the dimension of R m by 1 is m only, so the dimension of, because CA is a subset of R m by 1 vector space, so the dimension of CA should be less than equal to this m, right? So please mark this as 2. So from 1 and 2 we get the dimension of column space of A is less than equal to minimum of mn, right? And the dimension of column space of A is nothing but the column rank of A. So the column rank of A is less than equal to minimum of mn. Hence the result, right? Okay. There is a very important remark over here which states that if A is an m by n matrix and A dash as its transpose, then row space of A is equal to the column space of its transpose, and column space of A is equal to row space of its transpose. Easy to learn? Alright. Therefore, row rank of A is equal to column rank of its transpose, and column rank of A is equal to row rank of its transpose, right? So this is very important remark. Please note it down. Okay, thank you.